The reported pass rate for the Journeyman electrician exam in Washington state is 60%. I was not able to find any specific information regarding the pass rate for the administrator exam. There is a proposal to potentially change the exam passing score from 70 to 75% to maintain reciprocity with other states. When preparing for any electrical exam, it is crucial to understand the specific requirements and content covered. These exams often assess knowledge of the National Electrical Code or NEC as well as state and local electrical codes. A solid understanding of electrical theory is essential, including Ohm's law, which states that voltage equals current times resistance. This relationship is fundamental to understanding electrical circuits and troubleshooting. You should also be familiar with series and parallel circuits, and how voltage, current, and resistance behave in each type of circuit. Understanding the different types of electrical conductors is also important. Conductors are materials that allow electricity to flow easily, such as copper and aluminum. The size of a conductor is measured in American wire gauge or AWG. The smaller the AWG number, the larger the conductor. Larger conductors can carry more current. The NEC provides tables that specify the ampacity, or current carrying capacity, of different conductors based on their size, insulation type, and installation conditions. For example, NEC Table 310.16 provides ampacity values for conductors rated 0 to 2000 volts. You should also be familiar with different types of insulation, such as THHN, THWN, and XHHW. Each type of insulation has different temperature ratings and is suitable for different applications. Understanding how to properly size conductors for different loads is a critical skill. The NEC provides guidelines for calculating the minimum conductor size based on the load current and any applicable dating factors. Dating factors are used to reduce the ampacity of a conductor when it is installed in certain conditions, such as when multiple conductors are bundled together or when the ambient temperature is high. Overcurrent protection is another essential topic to understand. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds the breaker's rating. Fuses are one-time use devices that melt and open the circuit when the current exceeds the fuse's rating. The NEC specifies the requirements for overcurrent protection, including the maximum size of the overcurrent protection device for different types of circuits and equipment. Grounding and bonding are also critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Bonding connects all metal parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences between different metal parts, which can also cause electrical shock. The NEC provides detailed requirements for grounding and bonding, including the size of grounding and bonding conductors, and the methods for connecting them. Understanding electrical equipment, such as transformers, motors, and generators, is also important. Transformers are used to step up or step down voltage. Motors convert electrical energy into mechanical energy. Generators convert mechanical energy into electrical energy. The NEC provides requirements for the installation and protection of electrical equipment. You should also be familiar with different types of wiring methods such as rigid metal conduit, electrical metallic tubing or EMT, and non-metallic sheath cable, commonly known as Romex. Each wiring method has different applications and requirements. Rigid metal conduit is a heavy-duty wiring method that provides excellent protection for conductors. EMT is a lighter-weight wiring method that is commonly used in commercial and industrial buildings. Romex is a flexible wiring method that is commonly used in residential buildings. You should also be familiar with different types of boxes and fittings that are used to connect and support electrical wiring. Boxes are used to enclose electrical connections and provide a safe and accessible location for making splices and terminations. Fittings are used to connect conduit and cable to boxes and equipment. The NEC provides requirements for the installation of boxes and fittings, including the minimum size of boxes and the types of fittings that are permitted for different applications. Understanding electrical safety is paramount. Always to energize circuits before working on them. Use appropriate personal protective equipment or PPE, such as safety glasses and gloves. Follow lockout/tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards of electricity, such as shock, arc flash, and arc blast. Arc flash is a dangerous phenomenon that occurs when a short circuit creates a high-energy electrical arc. Arc blast is the pressure wave that is created by an arc flash. Both arc flash and arc blast can cause serious injuries or death. It's beneficial to review basic electrical principles, which include alternating current or AC and direct current or DC. Alternating current is the type of electricity that is commonly used in homes and businesses. Direct current is the type of electricity that is produced by batteries. AC voltage changes polarity over time, while DC voltage remains constant. Understanding the difference between AC and DC is important for working with different types of electrical equipment. Another area to focus on is reading and interpreting electrical drawings and diagrams. Electrical drawings and diagrams provide a visual representation of an electrical system. They show the location of electrical equipment, the wiring connections, and the control circuits. Being able to read and interpret electrical drawings and diagrams is essential for installing, troubleshooting, and maintaining electrical systems. It's also important to have a good understanding of the NEC. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years. The NEC is not a law, but it is widely adopted by states and local jurisdictions. Familiarity with the NEC is essential for passing electrical exams and for working safely as an electrician. When preparing for the Journeyman exam, consider taking practice exams to assess your knowledge and identify areas where you need to improve. Practice exams can help you become familiar with the format of the exam and the types of questions that are asked. Study guides and online resources can also be helpful. There are many resources available to help you prepare for the Journeyman exam, including textbooks, study guides, and online courses. Consider joining a study group or working with a mentor. Working with others who are preparing for the exam can provide support and motivation. A mentor can provide guidance and advice based on their experience. Finally, to stay up to date with the latest changes in the electrical industry. The electrical industry is constantly evolving, with new technologies and regulations being introduced all the time. Staying up to date with the latest changes will help you to be a more knowledgeable and effective electrician. Keep in mind specific calculations such as voltage drop, which is the decrease in voltage along a conductor due to its resistance. The NEC provides guidelines for calculating voltage drop to ensure that equipment receives adequate voltage. The maximum allowable voltage drop for branch circuits is typically 3%, and the maximum allowable voltage drop for feeders is typically 5%. You should be able to calculate voltage drop using Ohm's law and the conductor's resistance per unit length. Another important calculation is short circuit current. Short circuit current is the amount of current that flows during a short circuit. It is important to be able to calculate short circuit current to ensure that overcurrent protection devices are properly sized to interrupt the fault current. The NEC provides methods for calculating short circuit current. Additionally, you should be familiar with power factor, which is a measure of how efficiently electrical power is used. Power factor is the ratio of real power to apparent power. Real power is the power that is actually used to do work, while apparent power is the total power that is supplied to a circuit. A low power factor can result in increased energy costs and reduced system capacity. It is important to maintain a high power factor to improve energy efficiency. Consider reviewing motor calculations, including full load current, starting current, and overload protection. Motors are a common type of electrical load. The NEC provides tables that list the full load current for different types of motors based on their horsepower and voltage. Starting current is the current that a motor draws when it is first started. It is typically much higher than the full load current. Overload protection is required to protect motors from overheating due to excessive current. The NEC provides requirements for overload protection based on the motor's full load current. Focus on control circuits, which are used to control electrical equipment. Control circuits typically use low voltage wiring and components such as relays, switches, and sensors. Understanding control circuits is essential for troubleshooting and maintaining electrical equipment. The NEC provides requirements for the wiring and protection of control circuits. Be sure to review grounding electrode systems, which are used to connect electrical systems to the earth. Grounding electrode systems provide a low impedance path for fault current to return to the source. The NEC provides detailed requirements for grounding electrode systems, including the types of electrodes that are permitted, the size of the grounding electrode conductor, and the methods for connecting the electrodes. Consider also reviewing transformer connections, which include delta and Y connections. Transformers are used to step up or step down voltage. Delta connections provide a 3-phase 3-wire system. Y connections provide a 3-phase 4-wire system. The NEC provides requirements for the wiring and protection of transformer connections. Finally, review hazardous locations, which are areas where flammable gases, vapors, or dust may be present. Hazardous locations require special wiring and equipment to prevent explosions. The NEC classifies hazardous locations into different classes and divisions based on the type and frequency of the hazard.